Hello everyone. This video presents my final year project titled Comparative Performance Analysis for Efficient Inference on Edge Devices with Vision Transform. This is a part of my final year project in Electrical Engineering Department. Vision transformers have been extensively used in image processing applications, providing better performance than traditional convolution neural networks by getting spatial and global relationships as well of the image. This is enabled because of the use of the self-attention of the transform models, which helps in getting those global relationships. The working of VID model is such that it divides the image into multiple patches. It assigns position embeddings to it, and those tokens are then passed on to the transformer encoder, where self-attention model comes into action, and various layers, that is the MLPs and normalization layers, process the data, and we get the final solution. But the problem with the VID models is that it requires a lot of processing and also consumes a lot of resources. Given the huge processing it does, even the inference time of VID models is less than the CNN. To solve this bottleneck, many researchers have provided various solutions, suggesting modifications either in hardware or the model structure. This study focuses on comparing all these models and get better performance by focusing on the number of parameters required to achieve the optimum accuracy and how we can make changes to the hardware for accelerating the processing time. This methodology discusses 7 different models as shown over here, out of which to accelerate or to speed up the hardware, the Vita model and Heatwave models are there, where in Vita model, there is suggestion of making use of 2 MAC units in order to pipeline the execution, pipeline the computation. And in the Heatwave model, token pruning is suggested in order to process the informative and non-informative patches and effectively get the results. The David model over here suggests decomposing the larger model into multiple small models and processing it in parallel and assembling the whole data using the knowledge distillation method to retain the accurate information as discussed by the author of this model. Furthermore, we have the mobile VIT architecture, edge VIT, and the mode model, which makes use of the combination of convolutional networks and the transformers to effectively fetch both global and local information in order to get the better accuracy. One important point over here is like this study takes mobile VID architecture as the benchmark in order to compare the accuracy of all other models and how all other models are performing as compared to the mobile VID architecture. So our discussion would be based, this study is based on figuring out which model performs much better with respect to the mobile VIT in terms of the number of parameters used and what is the accuracy that they provide. Lastly, we have the dynamic transformer, which suggests making use of large super transformers and training the sub transformer as per the device specification by making use of this super transformer. More in-depth details of all these models have been given in the report. The results of the analysis shows that we can get better accuracy, but it comes with a large number of parameters. And as we know, the edge devices have those are resource constraints. So that's why we need less number of parameters. That's why we need less number of parameters to process and to store the information. And to enable that, we have different lighter version of this models. Like for example, for mode, we have the tiny mode. For the edge VIT, we have iEdge VIT XXX, which makes use of less number of parameters, but it does comes with little penalty in accuracy as well. Also in hardware, we can see if we make a better design of the accelerator, we can get better frames per second, also less energy and power. More information on the results and analysis are also mentioned in the report. In conclusion, this study suggests that combining the abilities of CNN and transformers would help in achieving better performance with less number of parameters, which we can see in the edge VIT architecture. And also, in order to get better processing time, we can make efficient design so that the processing power is the consumed processing power is less, and a better inference time can be achieved by making wiser use of the matrix multiplication that we have to do in the vision transformer. Now, the aim of the studies is to serve for future is to serve a groundwork for the future research in the field of vision transformers. And when one wants to deploy the vision transformer in edge devices, also it provides a brief comparison of various available solutions till when the study was done, and this gives this gives a basic idea of how we can make efficient use of the model by making certain tweaks into the design structure or the hardware. For more information, please refer to the report where in-depth introduction of the VIT models and the different methodology that has been used in my study, and the discussion on analysis and results, and what is the conclusion after doing this study has been mentioned.